everyone. So this is a kind of like a free part series workshop on how to use ParaView for CFD flow visualization. This is something I've wanted to make for quite a few years, and I finally got around to sitting down and generating it. So just a little bit about myself. I recently got my PhD at University of Toronto. Um, my work is computational fluid dynamics based (CFD), and I've been using ParaView for 7 years to date. ParaView is fairly powerful and it's also open source, and you can actually run it on HPC supercomputer clusters. And kind of leads into their motivation and goal for the series. The idea is to have kind of like a walkthrough, something you can watch on a second monitor as you explore ParaView. And hopefully by the end of the series, you'll be able to generate things like streamlines, effective plots on contours, Q criterion contour animations, and just to present your data neatly. So the workshop is broken into three main parts. Part one is quite basic in a sense that it's primarily aimed towards users with near zero experience. So perhaps you've just downloaded ParaView or just trying to try it out, then this would be ideal for you to start. We cover the basics like low file, safe state, a little bit on the filters. And then part two, we look at something a little bit more advanced, things like true criterion contours, generating effective plots, and also exporting VDK and dealing with transient data. And finally, in part three, besides streamlines, because when I recorded, I realized I forgot it in part one and two. So I ended up in part three. And we're also going to primarily focus on applying ParaView in a HPC environment, both with and without the GUI. So the version of ParaView I'm using is 6.1.1. Prior to this, I was using 5.11, but I've kind of downloaded this for the purpose of this series. This is the I think most latest version at the to the date of making of this video. So if you're downloading the latest version or same version, it should be near identical for what you're seeing. And just one thing I want to mention, in ParaView, when you go into apply or basically using ParaView off screen, you want to make sure your client version locally is the same version as the one on the module you loaded on the HPC. Sometimes you might have to re-download a slightly older version of ParaView because if the version doesn't match, then the ParaView off screen won't work properly. So, just quickly to go through the agenda or what we're going to cover in part one before we launch ParaView. So again, this is going to be very fundamental, assuming you have near zero experience on using ParaView. Um, we're primarily working with steady state results today, so there's only one time step. This is quite common with rand results, although the example we're using today would be actually a LES result, but it's only one time step. It works basically the same. We're going to touch on some of the main things like how to apply simple filters like section view, calculators, line plot, safe state, quite important, and then a little bit of cosmetic things like the color map, legends, and camera angles, and also axis grid, which is quite useful. Okay, so I've just launched a ParaView 6.1.1. Prior to this, I was using 5.11, so this should be fairly similar, if not identical, to what you're seeing if you just downloaded ParaView. Now, first thing first, I actually recommend going under Edit and press Reset to Default Settings. Um, and the reason is that if you have prior versions of ParaView, it might sometimes mess up the pathing. So when I first downloaded this, it would not load the file right. Um, Now, if you had prior versions, then you can try loading a file just to make sure it's fine. If not, it doesn't hurt to reset it to default settings. Now I'm gonna relaunch ParaView just for the reset session or default reset. Okay, so first we're gonna load files. You can either press the open folder button on the upper left, or you can click file and then open. Now, the default route is gonna be basically where you downloaded your ParaView, and you have to locate your files. Now, in this case, I moved the case to my desktop just for easy access, but ideally you probably want to save it on D drive somewhere where there's a lot of storage. Now, this is a standard open form case layout. You have the initial zero directory, you have like an output constant system. Um, Now, in when you run an open form, it's not going to have this thing called dummy.form. Um, the reason is that OpenFOAM doesn't need it. This is a dummy to tell ParaView that hey, this is an OpenFOAM folder, and ParaView is almost tailored for OpenFOAM. It'll still load out data, but to unlock its full power, OpenFOAM data is best. Now, you can either just in Command Console or Terminal Ubuntu type touch dummy.foam or any .foam. As long as the folder ends in .foam, ParaView will recognize it. Now, you will press that button and then nothing happens except on the left. And this is a standard feature for ParaView. A lot of the things changes, you have to press the green button apply for it to actually update. And then you should see something like this. By default, it'll open the pressure field. Um, and a cool thing on the lower left actually shows your RAM. This is a, I guess, relatively recent addition in the last 2-3 years. Kind of tells you if you ran out of RAM towards the end. Um, let's look at the properties panel on the left first. Skip zero time. Most of the time, our flows are initialized at time zero, so ParaView is pretty smart, automatically skips it. Now, you can also unclick it, and then doing so, you have to reapply. And then now it's also going to load time equals zeros field, which usually is just not as exciting unless you mapped it over. Now, for now, your case type should almost always be reconstructed. Once we move into part 3 of the session or the workshop where we look at parallel processing, then that's when you want to redecompose. You almost always want to match up the number of processor. If you're running this, if you're reading this as a reconstructed view, you're gonna use one CPU. If you ask it to use more CPU on one folder or one reconstructed view, it actually slows it down. Now, here under here, mesh region is just gonna read the internal mesh by default, but you can change it to, let's say I'm gonna only render or read the walls of the geometry. So we can see the top is being hollowed out and so is the bottom. Sometimes this is useful for plotting and extracting things like wall shear stress or pressure coefficient. Right now we just change it back to a mesh. Another good thing for this is when you import your mesh, let's say your geometry and mesh is generated elsewhere, like myself, I use ANSYS, and maybe you forgot a patch, and this is a good way to see which patch is being missed when you're trying to debug your OpenFOAM. And for scrolling further down, we're going to have velocity, cell displacement. This is because dynamic mesh. Now, let's say I don't care about our V cell displacement and new T. I just want our velocity and pressure field. Now, this is going to reduce basically what ParaView reads, and it also helps speed up some of the calculations later when, let's say, we're trying to do a time average. Instead of time averaging everything, it's just going to time average what we've loaded. Why load additional stuff and do additional calculations if we don't need it? Um, if you scroll down, you can also adjust the coloring, but I tend to like to just do it on top here. Um, oh yes, so there's this gear button. This is pretty important. It's called Advanced Properties. I recommend almost always having it on by default, just so you don't waste time trying to figure out why some of the features that I'm mentioning or that you're using is missing. Now, when we first load a, let's say, going from pressure to velocity field, the color range is usually automatic in the sense that it reads everything and then pick the max and the lower. But that's not often ideal. So we have basically 8.7 and then all the way down to negative, which is not normal. Now let's switch from the pressure field to the velocity field. Now when we usually switch it, ParaView assigns an automatic color range for the Lincoln. And the way it does usually just read the maximum and minimum, but quite often that's kind of ugly. So we have upward of 36 and downward or minimum of 10 to the minus 5. So the best way to go around this is just pressing the rescale to custom data range. Just got a little double head arrow with C, and then you just assign your manual range. This enable automatic rescaling might be on by default. I tend to click it off and apply. And voila, this is already better. So it goes from 1 to 10. Um, Now the other three of his buddies, the left one is just rescale to data range, which is the default. Switch back to 36 and 10 to minus 5. Now this one, the T, I almost never recommend pressing this button. When you're dealing with transient data, especially LES, you have so many time steps. This is gonna put the ParaView into a very laborious process because then it's gotta read every cells for every time steps and then pick the maximum and minimum. Unless you're trying to debug, I would never recommend using this step. Now the other one that's also handy is rescale to visible data range. If you zoom all the way in or a different orientation, you can click it. And so instead of reading the maximum and the minimum of the entire mesh, it just reads what you can see the cells and then take the max and the minimum. Now let's switch back to our manual. Okay. Now, so far we're only looking at the edge of the mesh, and with CFD, most of the time, their interesting things are inside the computational domain, especially for external flow. And to get around that, we can do something called section view. Now, it's basically this little button here, slice data set with plane, but it's grayed out because we have to actually select the geometry we want to slice first. I'm going to go back to isometric view. Now, I don't usually like using these interactive cursors. I feel like it's just not very precise. Instead, what I do is that you can use X normal, Y normal, Z normal, and then you can adjust the region manually. So let's say I want to do a little further. Oops, that's too far. 0.1, yep. So 0.02 and then 0.04 changes basically the offset. Um, this is a lot more precise rather than dragging this manually and trying to match it up. And then once you apply, it becomes the section view. Now, one of the things that I don't like the feature is that this thing stays on and is very easily grabbing it by accident and then changing it. So what I like to do once it's set up, I toggle show plane and it makes it cleaner. Now you can retoggle this back on later on. Let's say I'm trying to offset it by a little bit, then it's kind of handy to see where the plane is switching to. Now, so far we're relying on the 3D field. Um, you can press this button to switch to 2D, and then usually when you switch from 3D to 2D, it kind of changes the angle a little bit. So if you're trying to output a screenshot, you almost want to always align it in 2D first. And then I should mention these buttons are going to be your best friends. These are basically automatic set orientations for the camera. Isometric and Z or XY, depending on geometry, would be the easiest, the fastest way. Now, another thing we're also going to do is contours. Now, we're going to hide this slice and then bring back up our original 3D geometry or 3D fill and click a threshold button, or sorry, contour. Oh yeah, they've changed the name to generate ISO lines or ISO surface. Same thing. Let's say I want to plot the velocity magnitude contour for 5 meter per second. Then what it does is that it runs the flow field and then it kind of encloses this region that has a 5 meter per second. Now if I change that to 1, that'll be bigger. And then we can change the coloring. Let's say we want to color it by pressure, and that's okay. So the contour itself is a velocity magnitude of 2 meter per second, but it can be colored by pressure. Pretty handy. Now, um, at this stage, we've done a couple of things, and what we want to do is save state. This is the equivalent of saving your file or your Word document. I'm gonna call this a version 1, or let's say testing v1, and it's gonna save it as a pvsm. Now what this does is that it saves what you've done so far, because if you close the folder, if you shut ParaView right now, what's gonna happen is that it's gonna forget everything, and then when you relaunch ParaView 6.1.1, it'll be empty. So I've just relaunched it, ParaView, from my start menu or shortcut, and there's nothing here, right? Two ways to load the state that you've saved. You can either do load state, or you can go to where you save the state and then just press on it. Uh, I still have ParaView 5.11 saved, so if I just launch it from my browser, it's gonna use the wrong version. So I'll go to File and then press Load State here. Now, because I relaunched the ParaView software, it's just gonna bring me back to where the case was installed. Now, luckily, I've already set this up recently, or used found the path, so I can click recent. But what you can also do is that, let's say this is the case that you're gonna be working on for a while. You can press this button next to favorite, and voila, it'll save you there. So say go to D drive and then go back, and voila. And then now we can read the PVSM file, and you can notice that the dummy.form is missing here. That's because we're only looking at load state. Whereas let's say if we open file, it'll be the opposite. The load state that we have here is not visible. So you gotta know what you're opening. You're opening in the folder or the state. Now, when you load the state, you can actually change the file names. We'll look at this further down the road. But this is a very powerful tool where, let's say, you set this up for one case, but then you want to change a separate case that you're doing the post processing on, and that's how you change it. But for now, let's just say we're using a state name. Now, what load state does is that it saves our setting, but then ParaView has to redo all the calculations. So depending on how vigorous your tree is, your pipeline is, it's gonna get longer and longer during the load state. Here we only did some very light calculations, so that's why the load state only took a couple seconds. Some of the things that are not conserved are things like show plane. Oh, annoying, but oh well. But you can see that the color legend are safe, the range is safe, and oh, I had trouble reading the pressure field. Let's try to refresh it. Oh, there we go. Yeah, I guess sometimes when you just reopen it, you have to toggle the visibility, or you might have to do a refresh from the geometry just for it to go through. Uh, okay, the next step is calculator. Now let's go back to our slice view and let's look at our velocity magnitude. Uh, or let's do Vy, how about that? And this is kind of a scenario where the rescale to visible data range becomes quite handy. Um, and this kind of shows me what I'm working with at that slice in terms of a range. Now, let's say I want to normalize everything with a length scale or like a velocity. So this little calculator button, and you can press on it. And now it's very important that you highlight what you're trying to apply the filter, the calculator filter on. Um, you can click either point data or cell data. And down here, there's scalars. And if you're reading open form data, these are all nicely laid out, and you can even use vector. So again, you do UI divide by, let's say 10. And then let's say our visible range is going to be -1 and 1. So right now we're basically plotting a custom range of color between our velocity UI in -10 to 10. So if I go back to our UI, so this is without a calculator, and do -10 to 10, it's gonna look ideally identical to what we're doing now. There is a slight change of the color legend, but overall the contours are more or less the same. Now we want to change the array name. We're gonna do norm UI, and then we're gonna have to reload it with the new name. Now this is a good time to talk about the color legend. So, yep. Okay. So I tend to like having the color map editor opened up on the right. It does take up some real estate, but it's good to know, or good to see what we're working with. So next to this triangle, there's these little settings that allowed you to reset it. Most of them are similar to what we have on the hotbar, but you can also choose presets, and a couple of ones I like would be Inferno, Woman, Kudo Warm is decent. It really depends on what you're trying to plot, really. In this case, because we have a 10 or let me reset it. So in this case, because we have a minus 10 to 10, what should be 1 because we're already doing normalize. Uh, so because we kind of have a symmetric data range, it's like 10, 0, minus 10, I like to have something that is white at the midpoint just to show, kind of visualize the zero velocity. But you can also use other ranges. If you're doing 0 to 10 instead of 10 minus 10, some of the white to darker color would be more ideal. Now, the color ligand here is kind of ugly, so we can change this by pressing this little color bar with the E next to it. Um, First of all, we can change the title, and this kind of goes into latex math, which hopefully you're familiar with. When UI divided by, I'm just gonna call it U infinity. There's no U infinity here, but it's a good way to show what the math equation can do, which hopefully doesn't crash it. Voila. Took a second, but now we're basically the ParaView software recognize these are latex math, so it changes it. Um, Now it does take a second or two, and that's without any bugs. So sometimes if you have a typo, it would get stuck there for a good 20, 30 seconds. So you might want to be careful about it. Horizontal title, voila. So we move it to the top, which is almost always more ideal. That's a great example. I'm trying to scroll down to find some of the settings I'm familiar with. It's being hidden, so you gotta press advanced setting, and then this gives you a lot more. Um, Automatic format. So let's say we're gonna change it to Civic. You can also use custom label. So in this case, you can manually input the tick. And in this case, I don't think we need 2. We can just 0. And you can also change the way it's being presented. Oops. And voila. You can probably also get rid of the C or the dot. Um, Now, if you want to change the layout from vertical to horizontal, you just drag it and voila, bounce it to one of the border, it will automatically readjust. Now, right now, this is a very smooth transition, but perhaps just a little too smooth. So if you scroll down to color discretization, you can reduce it. I like to have something between the range of 10 to 25. And this just gives you a more qualitative or easier to see what the thresholds are. But if you kind of do go overboard, it becomes a little too abstract. So play around and pick the range that looks best. Now, we've done all this, and the best thing to do now is to save state. I cannot stress it enough. Early on, you're going to be making mistakes when it comes to peer review. Sometimes you apply these illegal operations, and ParaView would not know what to do, and it's going to crash, and then you're going to lose progress. So make a habit of saving, and what you can even do is save as a version 2. It's a good version control. I strongly recommend against having dates and time. You can always just kind of trace back up. If version 2 crashes, you can just reload version 1. So now we're gonna look at threshold. Um, this is pretty similar to contours, but in this case you have a lower and upper bound, so you can readjust it. Um, it's an interesting range. I guess pressure field. You can kind of visualize it with the slide bar, but I tend to like using typing actual values in. Um, but this does require you to have a really reasonable knowledge of the flow field. Now, let's take a step back and talk about the tree, especially on the calculator. Now, here what I've done is that I took a slice from the 3D domain and then I applied a calculator onto it, and therefore what I've calculated is just a slice. Now, if I were to, let's say, shift that domain by 0.02, just going to show it, then the calculator also moves with it. So we're no longer modeling the cavity or the little blob underneath. Um, what I actually recommend instead of doing a calculator on the slice is that we calculate it based on the 3D geometry. So I'm going to call this calculator hole. And then just do the same thing, but this time let's do a vector divided by 10. And then I'm gonna do u vector. Yeah, u vec divided by, or u vec non, non, u vec. And similar to how our vector velocity field, we have ux, uy, uz, so we don't need multiple calculator. And then we can take a slice here, we're going to do set normal, and come back out to the same thing. Just going to do -1 and 1. And the good thing with this is, let's say I want to have this plane, but also a second slice. Then I click the calculator hole, make another slice. Let's say this time I want to do a y normal. Oop, wrong field. And voila, we don't need to have a bunch of calculators in this way. The calculator just needs to be done once. And this also helps when you reload the state, it just have less operations that is required. And again, good habit is to save state. Now, the next thing is line plot. So I almost always recommend doing line plots on the 3D geometry. When you do line plot on 2D, it kind of like a slice, it gets a little weird. So let's say I want to do a slice, let's say somewhere around here, a line plot, and plot the velocity halfway through the neck. So there's going to be a plot over line over here. Now, by default, what it does is that it goes from one end of the domain to the other end. Not very handy. You can drag the starting and ending point manually, but we're working with a 3D geometry. The depth gets lost in translation sometimes. So this is best done manually. You can kind of pre-line it up with some of these convenient axes or presets. So if I hide it, it kind of shows you how they look. Now, I know my geometry reasonably well, so I know that at the neck is going to be at mid span 0, 0. Um, I know that this is 2 mil in diameter, so minus 0.001, 0.001. And I'm not too sure about the altitude. So I'm just going to do 0 and see where it is. And it might be hard to spot, so we can hide the geometry again, and voila. So I was wrong. There's a little bit of an offset. Um, 0.015. And voila, that's where I want it. Again, this requires at least a reasonable amount of understanding on your geometry. Now, when we apply the line plot, usually I just bounce it on the right, and I tend to just close that and then open a new tab instead. There's a lot of options. We're just going to go with the line chart view and then toggle visibility. So it just shows you basically everything that is being sampled. Um, let's just say we only want to look at the velocity field, and it's gonna readjust and then plots the UMAC, and then if we plot UY, UX, Z, readjusts accordingly. Now, the line plot feature in ParaView, in my opinion, is okay for just quickly visualizing your data. It's quite limiting. You can adjust the axes, so to do that, uh, you have to kind of scroll in and out and drag yourself around in the view. Then it unlocks the axes option, which is right here. So it allows you to adjust the minimum and maximum. You can realign it. Um, but what I tend to like is just end up exporting these as CSV to plot in ParaView, in Python or MATLAB. So to do that, you click another new layout window, and instead of just making it visible or line chart, you do a spreadsheet view. And this is going to allow you to export it and download it in a CSV format that is a lot easier to work with. And you can click this little table here and just kind of decide what you want to see in export. Things like point ID, arc length, they're a little useless for plotting, at least in my application. And so in the end, we end up with point displacement, pressure. The points is very important. You need the location of where the line is, or the data point. Which also reminds me, if you go back to the properties, there's a resolution of 1,000. What this means is that in this little line, it's sampling 1,000 times, but I know the mesh only has about, um, if we click on the geometry, I can change it to the mesh. I know roughly there might be at best 20 to 50 data, and if I show the slice view at midspan, I know that there's only about 30 at best, if not less, so having 1,000 samples over there is really overkill. Uh, so let's just trim that down to 100, just saves everyone some computational time. And you're not losing much, honestly. There's a lot of duplicate resampling. And then when you export it to CSV, let's say, uh, data set one, then we're gonna open it. The header tells you what you exported, and you can see that the stuff that we hidden from the table, like the arc length, point ID, they're less useful, gets hidden away. You can also load this into Excel, but I strongly advise against using Excel for analyzing CFD results. Um, with generative AI, it's really easy to make a script that reads CSV nowadays in Python or even Google Colab. Excel is not meant to analyze CFD results. It just doesn't have the computational power set up for it, in my humble opinion. Um, okay, two things before I wrap up the first tutorial. Camera angle. So far, we've kind of done some manipulation. So let's do the threshold or contour because it's pretty. It's 3D. Oh, before we forget, we've done all this thing. Save your state. Now we've added another thing, so I'm gonna call it version 3. You don't have to be as vigorous. You can just kind of keep updating your versions too. Uh, Now we have this thing. So far, we only look at isometric side views. Uh, but let's say I kind of didn't like this angle, so I kind of readjusted somewhere around here. Maybe spin around a little bit. Okay, this is the angle I want. What you can do is that you can save this as a preference. So on your upper, um, for you guys, these should not be here, but it kind. Ooh, I hit the wrong one. Is that the common? Nope. Macro two bar. There we go. So for you guys, this should be empty. And what you can do, and let's say this is the angle you want, click the this button, and voila! Suddenly you have a new viewpoint. So let's say I kind of do a bunch of crazy stuff, and then I can just reset it back to that by clicking that button. Now, once you have a couple of orientation, it's gonna start getting hard to keep track. But that's when the range button gives you a pretty nice way of doing things. So instead of current viewpoint, I'm going to say this is my ISO view and this is my garbage view because I don't know what it's doing. And when you hover over it, it's going to show you ISO and garbage. Now, let's say, well, I don't like the garbage view. I kind of want to replace it with a side view. But kind of pull a little to the left, you can override it by clicking current viewpoint. And now suddenly, voila, our garbage viewpoint is being overwritten by an XY view. Now you would want to be careful because it's very easy to kind of just accidentally click a button and voila. But you can actually export them just to have a backup. And you can also import it. And then if you don't like it, you can just straight up cross them out. Now, another, I would hesitate to call it advanced, but it gives you more control or more in-depth control of the camera angles using this adjust camera. Um, Now, this kind of requires quite a bit of very intense knowledge of your geometry. The only thing I tend to play around with is the center of rotation. If I'm in 3D and I'm dragging things around, the center of rotation kind of changes all the time. I know that my nozzle is at 0.02, so I'm gonna fix that. So basically, what I've done is that I fix the center of rotation to this nozzle point. And now when I'm rotating, we can kind of see that that becomes our center of rotation. Now let's say I want to have the bottom as a center of rotation. Oops, 0. And then now we're rotating as that's a center of rotation. I find this to be the most useful tool. Another one is our zoom. let's say we have something very precise. Let's go back to our isometric view. And let's say this is a little too small or too fast zooming in. Uh, Now the default setting is 1.5, but what you can do is let's do 1.01. Why are you fighting me? 1.1. Okay, I guess I have to adjust it with the tiny button. And then that gives me a lot more manageable zoom. You can also do azimuth, elevation, roll until you get the perfect one you want. Um, this is more handy when you're actually generating the publication figures. Very minor adjustment. Now you did all that, and again, I sound like a broken record. Save your state. We're going to look at the grid axes now. Um, let's just. So all I've done is that I've basically taken a slice. This is the old mid-span slice, just to kind of give us a background. Um, if you scroll down and all the way down, you can also search axis grid instead. Um, Click it, and it'll give you an automatic axis. Usually, it's not very good. So you press the edit button, this window pops out, and you can kind of work from there onward. Now, similar to a lot of other settings, you want to toggle advance on right away. You can rename the axis. So let's say instead of X, I want to do latex math, X divided by D, D being the diameter of the little nozzle, and I'll render it accordingly. I tend to end up just making these empty because I have yet to find a way to adjust the location of the axis with respect to the text. But if it works out for your case, you can keep it. You can also change the size, the font, and the color. Um, the face to render is primarily for 3D. So if you look at this in a 3D view, we can kind of see that it's quite a different dimension. So it almost label everything we can see. Let's just add this dummy axis back in, and we can kind of toggle some of these, and it changes what's being rendered and what's not. This really depends on your angle and your geometry. So play around with what you end up having. You can also change grid color. Black is the standard way to go. And then you can also press show grid, especially on a side view. Let's hide the background, and voila, shows you the grid mark. Axis to label, pretty self-explanatory. So high, minimum, Y. It's kind of interesting. So the axis that I hit is the x-axis, but because it's located at the bottom, so that's why it's min y ends up being the x-axis at the minimum that's being hidden. Whereas if you want to hide the top, that'd be max y, and voila. You can also hide max x. Um, Notation, you can change it. I tend to like fix, and then you can change the precision. And custom labels are gonna be your best friend. So right now the tick is a lot more too frequent than what I like, so I'm gonna change it to 0. Let's do 0.05 and 0.1. And for that, it has adjusted accordingly, and it also changes the grid line. So the grid is only outputted based on your tick max. Or axis label, I should say. Um, okay, custom bound and data transform. These are very important tools. So kind of to visualize it, I'm just gonna toggle back on our automatic. Now, everything is just scaled to the absolute here, and the mesh has an origin 0, 0, 0 at the bottom. Let's say I want to shift that origin to the nozzle here, where this red and the blue meets. I know the neck height, or that offset is 0.02, so the first column is X, second column Y, third column Z. I change that, and our zero has actually shifted up. So let's just set it back to zero. Our zero is at the bottom, and that shift the whole scale linearly up. And we can also adjust the data scale. So I know that my nozzle has a diameter of 2 millimeter. Let's do the same for the x-axis. And by changing that scale, what I've done is that I've normalized everything. And so I've offset it, but also normalized it. So it's now actually x divided by d, or on the y-axis, it will be a y divided by d, where d is equal to 0.002. Very handy tool. And then let's say, well, I kind of don't want this area. Then you can use the custom bound. Um, 0 to 1. So x would be minus 1. And I guess 0.002. 0.002. Yep. You can play around this. So the custom bound comes before the data transform, so it's not affected by the data scale. So this uses the absolute. What I recommend is that kind of use the custom bound to readjust the frame you want, and then you can kind of go back to data scale and then go to data scaling. Finally, you notice the background is gray. Not a big fan of it. So let's switch it to a white background. Um, where is our background color? There we go. It should show at the bottom. And click this, change it to white. Now you're probably gonna have to change your grid text to black. Grid color, axis label. That's better. Um, Now we still have this kind of annoying background here. This is just our slice, but um, it's supposed to be white actually. But the reason why it came out gray um, is under the lighting setting, the ambient. So if you want it truly white, then you have to make it max to 1. But I usually use 0.4, even 0.2. Yep. Just to kind of give it like a slight tint. Um, this is more important when, let's say, we have our velocity field normalized, and let's say our color range is, oops, yeah, let's do one to cool, and let's give it more range. So we expect most of the flow field to have zero velocity, um, and but then it's kind of not because of the tint of the background. So we change that to 0.4, and then voila. Now you're gonna have to change the legend color as well. Let's do it black. Does that fix it? Yep. And for a lot, you can also hide a grid axis, and this is almost ready to get screenshot and just stick it onto your document. Um, Last thing, save state. Don't forget that. I guess you can also save the screenshot. I'm just gonna go pick one. You can change the resolution things, but I tend to stick with the default. You can also do save screenshot here, but there's a shortcut button here. Now, if we look at the figure, the resolution kind of changes a little bit, or the aspect ratio. This is not exactly the view we have. Um, we'll talk about camera angle more in the next session, but you can also easily just crop this. Um, okay, I think that wraps it up for this workshop, and I'll see you in the next one.